Hey, what is up guys, Omogonix here and welcome back to a brand new tutorial here on the channel. So this is part 8 to my tutorial series where I teach you all how to make a basic horror game in Godot. Now, I was just thinking, what on earth is this random capsule here? But it's from the last part where I actually showed you guys how to make scare triggers. And what this is, it's basically like it's meant to represent like a creature or something that runs past the hallway. So yeah, that's what that's meant to be there. But anyway, so what I'm going to be doing today is I'm actually going to be showing you guys how to make a basic AI monster which can chase you around in your game. So yeah, we're going to be doing that today. And I don't know what else we'll be doing today. We might do other stuff if the AI doesn't take too long, but if the AI does take enough time for it to take up the whole tutorial, then that might be the only thing we do today, but I guess we'll have to wait and see. So anyways, without further ado, how about we get right into it? And by the way, if you want to, be sure to like, comment, and subscribe for more if you do enjoy, and let's get right into it. So first up, before we do get our AI into our game, we need to make sure that we set up our nav mesh so then it can walk around. So if you've ever used the Unity game engine before, you would know what nav mesh is. So the way it works in Godot is somewhat different, but I will teach you guys how to do it. So what we're going to do is with our floors and walls, we're going to actually right click on them, and we're going to go reparent to new node. Alright, so now what we're going to do is we're going to search up navigation, and you should find the navigation region 3D. So now you want to select this, and boom, so now our floors and walls are now children of the navigation region 3D. So now what you want to do is in your inspector, in the navigation mesh section with the navigation region 3D selected, you want to select on where it says empty, and then go new navigation mesh. And then boom, so now we have a new navigation mesh. And then what we'll do is in order to bake your nav mesh, you need to have your navigation region 3D selected. And up in the top corner here, well, not in the corner, but more so in the middle of the window here, you can see where it says bake nav mesh. So when you click this, it will then bake your nav mesh. So there are a bunch of customizations that you can do for your nav mesh. If you click on the navigation mesh here, there's a bunch of stuff you can change. Right now, there's nothing that I really want to change. I am happy with how it is. However, we could probably lower it a bit. So if you want to do that, here's how you would do that. So here we have the cells option. So you can actually like change the height of the cells and also the size of them. But yeah. So now we're going to go bake nav mesh again, and boom. So now that's made the cell size smaller, and it's also made it lower as well. So the cell size, for those of you who don't know, I'm pretty sure that has to do with here, wait. Let's actually see what it says on the description so then I can describe it properly. The cell size used to rasterize the navigation mesh vertices on the XZ plane must match with the cell size on the navigation map. So yeah. So if we change the cell size to something like 0.5 and then we go bake, as you can see, it makes the vertices much larger, but then the smaller the cell size is, the more vertices there are basically. So yeah, when you have a smaller cell size, it kind of makes your nav mesh more accurate. So yeah. Also, something that's bothering me here is these doors here. I thought the doors were being affected by the nav mesh, or the doors were affecting the nav mesh, so then the creature couldn't walk through. But it turns out they're not, because the doors aren't children of the navigation region 3D, because fun fact, the navigation region 3D will only affect objects that are in the actual, that are children of the navigation region 3D. So something that should be children of the navigation 3D is certain bits of furniture, like the tables. So you might want to drag your tables under the navigation region 3D. You know, if you have drawers or anything like that, then drag them under. Yeah, them sorts of things should all be in it as well. So then we'll go bake nav mesh again, and boom, as you can see now the tables are part of the nav mesh. So I will work on fixing up the doors later. For now, this is all goods. So that is how you use the nav mesh in your game. In fact, Here, wait, let me actually make a little edit here. So if you go into the Agents tab here on your navigation region, on your nav mesh, well, they're basically the same thing. If you go change the radius, I think this might fix up the issue here that I'm having with the door, and yeah, it does. So there we go. So if you make the radius smaller, if you're having a similar issue to me where you find that your AI can't walk past certain parts because it might be a bit too thin for them, if you change the agent radius on the actual navigation mesh, then yeah, then your monster will be able to walk through these doorways if they're thin, so yeah. Otherwise, if your doorways are thick enough, then you shouldn't really have to do what I just did there, but you can still if you want to. Like if you want your AI to be more, accurate with, how it's able to move around the map or whatever. But yeah, just do whatever's more right for your game, of course. Alright, so now that we've got the AI all done, sorry, not the AI, now that we've got the nav mesh all done and set up, how about now we get to making our AI? So what I'm going to do first off is, because I've got a lot of these tabs open here, I'm actually going to close these. Just close a bunch of these tabs so then we don't have them all, open. Just going to close them. There we go. I think that's enough closed. So anyways, what I'm going to do is I'm going to create a new scene. It's going to be a 3D scene. And what I'm going to do is I'm going to change the type of this parent object here to a character body 3D. There we go. And I'm just going to call this monster. Alright. So now we're going to give it a collider. So we'll go collision shape 3D. And we'll give it a capsule collider. A capsule shape, I should say, as it's called in Godot. Same thing, pretty much. But yeah, so now I'm going to add a mesh instance 3D so then we can actually see our monster in the game. So this is just going to be a basic capsule once again. And so then we know which way the monster is facing. What I am going to do is I'm just going to duplicate this capsule mesh here. And then I'm going to decrease it in size, and then I'm just going to put it more over here. Yeah. And then I'm just going to save it into my scenes folder. And speaking of saving as well, I just noticed that my current level scene is unsaved, so I'm just going to save that. There we go. Make sure you always save your project, it's very important. And also make sure that you back up your projects as well, that's important too. So yeah, and I'm going to add a few materials, well, just one material to this guy. Just to his eyesight there, so then we can actually see where he's looking from. There we go. Alrighty, so we've got all that done. Now what we need to do is we need to add a navigation agent. So we're going to go, where is it? Yeah, navigation agent 3D. Make sure you select that. And this will be important for our AI, of course. It's sort of like a nav mesh agent in Godot. Alright, so now that we've got all that basic stuff there set up, what we're going to do is we're now going to make a new script. So we're going to go select your parent object of your monster AI, go onto the script where it says empty, go create a new script, and you can call your script what you want. I'm going to call mine monster, and I'm going to have it in the scripts folder. Go create, and boom. So when you do create a new script on your character body 3D, sometimes if you don't select the right template, it will just come up with the standard character body 3D movement script, which, is good if you want to make a player, but, we don't want to use that here. So what I'm going to do is I'm just going to start off by getting rid of all this starter stuff. So let's get rid of all this. Alright, so first off, we're going to set the speed for our monster, so I'm just going to make a new variable and call it speed. And I'm going to make this equal to something like, we'll make it equal to 4 for now. You can set it to what you like to, of course. And then we're going to have a variable for the player. And then we're going to have a variable called caught. And you guys will see what this is used for. This is basically to determine when the player is caught by the monster. And then we're going to have another variable called distance. And so what this will be is this will basically be a float, and it will be the distance between the monster and the player. So those there are our variables that we'll be using. Now, something which I like to do with AIs as well is so then I make sure that they're on the ground. What I do is I do this. I go var gravity, and this is the same line of code that's basically used in the basic player controller script, which Godot starts off with when you do create a new character body 3D script. So it's pretty much just that line. So it's var gravity and then equals project settings dot get setting, and then in quotes physics 3D and then default underscore gravity. And boom, so basically what this is doing is this is making a new variable. In fact, we can put this with the other variables here. So this is basically just our gravity variable, and it is equaling to what the default gravity amount is in the physics setting. So if we go into our project settings here, and we search up physics 3D, and then there we go, the default gravity setting here is set to 9.8. So yeah. So basically what this means here is the gravity will be set to 9.8 since that's what it's set to in our project settings. And boom. So now we're going to go func underscore ready. So what the ready function is used for is this makes stuff happen at the start of the scene. It's like the start function in Unity. So what we're going to do is we're going to go player equals and then get underscore node and then root. And then we're going to go plus get underscore tree dot current scene dot name. So this is basically getting the current name of our scene, and then we're going to plus again, quotes, another slash, and then the name of your player. So if we go into my level scene here, what's the name of my player? It's just called player. So in my monster script, I'm just going to go back to my monster scene. In my monster script, I'm going to write player, and there we go. So now the player variable will equal to the player that's in our scene. Alright, so now what we're going to do is we're going to do a physics function, or a physics process function, I should say. So we're going to go func physics process delta. Alright, so the first thing we're going to do in our physics process is we're going to go if visible. So basically, everything in this function will only happen if our monster is visible. So if visible, and then if not is on floor velocity dot y minus equals gravity times delta. So basically what this is doing is this is basically so when the AI isn't on the floor, if the AI isn't on the floor, then they will fall to the ground multiplied by the gravity. So yeah. Now you don't have to do this in your games. If you don't want to implement gravity stuff to your monster, that's totally fine, especially if your game is just on like a flat surface. It doesn't really matter then. But yeah, this is just in case you do want to have this sort of thing, but you don't have to if you don't want to. So yeah. So underneath that, we're going to go var current underscore location equals global underscore transform dot origin. And then var next underscore location equals $ navigation agent 3D. So we're going to be getting the navigation agent 3D child. And then we're going to be doing dot get underscore next path position. And then we'll have var new underscore velocity equals to, and then we're going to be doing this in parentheses, next underscore location minus current underscore location dot normalized multiplied by speed. And there we go. So what these three lines of code here do is basically the current location variable will get the current location of the AI. So it'll be getting the AI's own global transform origin. And then next location, so variable next location, this will equal to the next path position of the AI. And then the velocity is determined here via the next location and the current location, which is being normalized and then multiplied by the speed. So now we need to set the velocity of our navigation agent. So we're going to go navigation agent 3D and then dot set underscore velocity. And this will be set to the new velocity. So what new velocity equals to here? that is what the velocity of our AI will equal to. So now we need to determine the look direction of our AI, so then our AI can actually face in the player's direction or in whichever direction it's moving. So we're gonna do a variable here. I'm just gonna call this look underscore dir, short for direction, equals, and then a tan2, and then in parentheses negative velocity dot x, and then comma negative velocity dot z. So this will actually make our AI look in the direction that it's moving. And if you're wondering what a tan2 means, I've looked it up before. I'm not really too sure. I remember once I was looking up how to actually make an AI look in the direction it's moving, and this method came up, so I've just been using this since. I don't really know how to explain it very well, but what I do know is it does work for what I do, so yeah. So now what we're going to do is we're going to go a space down, and rotation.y equals to the look direction. So what this will do is this will rotate our monster or our AI, whatever you want to call it, on its y-axis. So that means either left or right, and it will equal to the look direction. So yeah. So now we're going to be getting the distance from the player to the monster. So we're going to go distance equals, and then player dot global underscore transform dot origin dot distance 2, and then in parentheses we're going to do self, or we don't actually have to do self, we can just do global underscore transform dot origin, and there we go. So what this is doing here is this is basically getting the distance between the player and the monster. So yeah. So after this part here, there will actually be a bit which does have to do with the actual jump scare related stuff and the player getting jump scared, but we'll get to that in a bit. What I want to do first is I want to actually set up that kind of stuff first. So we're going to go back into the 3D scene, and with our monster, I almost just lost my voice just then. With our monster here, what we're going to do is we're going to right click, go add child, and a camera 3D. So this is going to be our jump scare camera. So I'm just going to rotate this on its y-axis like that. I'm going to have it so then it's facing our monster. And there we go. We'll bring it more closer, more up. There we go. And yeah, so this here will be our jump scare camera. I'm going to also rename it to jump scare camera. And boom. Jump scare camera. So now what we're going to do is we're actually going to do the jump scare related stuff. So if distance is less than equal to 2 and caught equal to false, what will happen is the player will be turned off. So player.visible equals false. The speed of the AI will equal to 0. Caught will also equal to true. So then this part of the script doesn't repeat over and over again. And then we're going to set our jump scare camera to true. So we're going to set that current to true. So basically what this does is it makes our jump scare camera be the camera which is currently being used in our scene. And then we're going to go await get underscore tree dot create underscore timer. So we're going to be creating a timer for the jump scare. And, we can add a variable here for the jump scare time. I'm just going to make this equal to 2. You guys can do that. You guys can do whatever you want for that. So then we're going to go jump scare time, and then false. So then the timer only works when the game isn't paused, and then dot timeout. And then after that, what will happen is get underscore tree dot create. Wait, no, we don't want to create anything. We want to change the scene. That's what we want to do. Change scene to file, and then in quotes, res, ... and then //. And then you basically just want to get like a scene of yours, like a death scene, basically. So if you've made a death scene, which I don't think we have in this tutorial yet. In fact, we haven't. I might have to teach you all how to do that in this tutorial. So, you know, just select whatever level you want to load into, whatever scene you want to load into when the player does die. You could even just have it that the scene itself reloads. So, yeah. If you want to add a bit of customization to the script as well, so then you can just change it up however you want to very easily. Something we could do here is we could do scenes and then quote there. We'll add a new variable, export var scene name string. So this will basically be like a public variable and it'll be a string. And then after the scenes thing here, we'll go plus and then scene name and then plus and then tscn. Just so then you have a bit more customization over that script. And yeah, so that's pretty much the physics process related stuff of that script done. Alrighty, so now we're going to make a new function, and this will be called update target location. And then in the parentheses here, you just want to write target underscore location, and then dot dot, and then navigation agent 3D dot target underscore position equals target underscore location. So basically, this is setting the target position of the navigation agent to where it wants to go, so its ultimate target location. And what is that target location? Well, it's whatever you want it to be, but in our case, it's going to be the player, of course. So yeah, so now we're going to do another function. So what this will be is it will be func on, and keep up with me here, navigation underscore agent underscore 3D underscore velocity underscore computed, and then parentheses, and then in here you just want to have it safe underscore velocity, and then the 2 dots, and boom. So now we're going to do velocity equals velocity dot move underscore toward safe velocity. And then in the comma here, you will want to set this to a certain value. I'm going to be setting mine to something like 0.5 or 0.25. Either one's good. So basically what this does is it basically makes sure that your AI isn't like bumping into things, I'm pretty sure. So it basically, you know, makes the AI's movement more safer, I guess. So let's say, for example, you have more AIs in your scene, right? And you have all them AIs like bunching up with each other and smashing into each other and stuff like that. I'm pretty sure what the safe velocity does is it's basically meant to like sort of keep them apart, you know, not bumping into each other, that kind of thing, I think. So, yeah. And also, another important thing which we need to do as well, speaking of the navigation agent 3D, is we need to actually go to avoidance, and we need to do avoidance enabled. So we need to enable avoidance, so then, yeah, the AI all works as planned, and, you know, yeah. And then the last part of this script is underneath the velocity line we just did, move and slide. So basically, what this will do is this will basically just make our character body 3D of our monster just move, you know, to where it needs to go to. So yeah, that is how we do the scripting. Now, of course, there is more setting up to do with this AI. We're not completely done here yet. Don't think that this is it, this is done, because it isn't. We've still got a few more things left to do. So now what we need to do is we need to actually select our navigation agent 3D, go to the node tab here, and see where it says velocity underscore computed. So you basically want to connect up this method to this here. So I forgot to put an underscore at the start of my on navigation agent 3D velocity computed function, but you don't need to name it exactly how it is. You can get rid of you know, that if you want to. You can name it whatever you like, this method, really. You could name it to Big Chungus if you want to, and then connect it up like that and it'll still work. So yeah. So anyways, now we're going to go connect, and boom. So now this here will all work. Now, our AI is not done yet. We still have one more thing left to do. So what we need to do now is we need to actually make a new script in our main level, like sort of like a level manager type of script, kinda. And I'll show you all what this is going to do. So let's get right to it. So what we're going to do is we're going to go to our level. So in case you can't tell, I am in my level right now. I'm just in the script view. So we're going to go select on the main level node, inspector, then we're going to create a new script, and I'm just going to call this like level manager. You can call it monster manager if you want to as well. You don't have to put this script on your main parent scene, by the way, like on the main parent object of your scene. You can put this on any node in your scene you like to, but yeah, I'm just putting on the main parent in my scene because that's where I want to put it. And I'm going to save this in the scripts folder, go create. So now what we're going to do here is in our process function, we're going to call a group. Now, that is actually one thing which I forgot to do, is I forgot to set the group of our monster AI, and if you're confused, don't worry, I'll get to that in a minute. But anyways, what we're going to do here is in our process function, we're going to write get underscore tree dot call underscore group. So the group that we will be doing, I'm just going to call my group something like monster, and then we'll do comma, and then update target location. So this is basically getting that method, that function from our monster script. So it's basically, so what the group does, right, is it basically gets all of the AIs that are in that particular group, and it makes that update target location function happen. So yeah. So what groups are usually used for is it's basically used to call a function on, all of something that is under a particular group. So let's say, for example, if your AIs, like what we're doing here, any AI that is under the monster group, and, it has the update target location function, that will basically be updated on all them AIs, so yeah. So basically calls the function on, a group of particular nodes which are tagged as a particular group. And then something else which we need to do as well is we need to actually do a player variable here as well. So we're going to go var player, and then func underscore ready, and we're just going to quickly get the player again. In fact, I'm going to go to my monster script and just copy and paste this part of the code from that. There we go. And then player dot global underscore transform dot origin, and boom. So basically what this is doing is this is getting the, so it's calling the monster group, so any AI that is in the monster group, it is calling the update target location function, and the player will be the target location. So yeah. Alright, so I think that there is pretty much our AI setup. Let's go into our main scene view, and what I'll do is I'll add in the monster, and we will give it a test, so hopefully everything all works here. Where is you? Monster, there we go. Oh yeah, and that's another thing too, I forgot to set the group of the monster, which is very important. So make sure that you select your the parent object of your monster, go node, go groups, and then you want to set your monster into your group. So whatever your group name is, mine will just be called monster. Then yeah, make sure you set that, so then the group can actually be called from that other script, the level manager script. And by the way, if you want to know how I actually learned how to do AI in Godot, I did watch a few Godot tutorials on YouTube on how to do it. So yeah, I do recommend watching other sorts of tutorials as well, since that can be very, very helpful. Alrighty, so now our monster is in the scene. And now, without further ado, I'm thinking of now getting started. So yeah, I've just set it to a regular, regular part of the scene. Our player is through here. Let's see how everything goes. So I'm going to go to my script view now, and I'm going to test out this game. Let's see if it all works. It turns out I accidentally typed in something wrong. Hold on, guys. Accidentally typed in a variable wrong here, just a little typo. Alright, now let's test again, and hopefully everything works this time. And what again? Another typo, because of course I copied and pasted this line of code from the other script, so it's gonna have that typo too. So, and now, third time's a charm, hopefully. Again, now what's up? Oh, I spelt it wrong. That's what the issue is. I spelt transform wrong. There we go. So now, hopefully this now works. And there we go, finally, after all them little issues we had, it now all works. Alrighty, so here we are. Pick up the flashlight, the key, and now we'll be on our merry way. What just happened? Alright, so one other thing that I just remembered I forgot to do is the death scene, so we will need to do that quickly. So I'm going to go add a new scene. We'll go into the 2D view. It'll be a UI scene, and I'm just going to call this death. So with my death scene, I'm just going to add a child node, go color rect, I'm going to add a basic black background. There we go. And boom. And then we're going to add some text. I'm just going to write def on the text. Increase its size. Theme overrides, font size. So if you want to increase the font size of your text, you just go theme overrides, font size. Then you can increase the font like that. Set mine to 100. Say def. Like that. And there we go. Gonna also call this background. And I'm also gonna call this def underscore text. In a future tutorial as well, I'll actually show you guys how to do randomized text on your def screens. So if you want to have random text show up, then I'll show you guys how to do that. We're gonna save the def scene. There we go. And boom. So now our def scene is all set up. So now with our def scene, we're going to create a new script, since we do need a script for our def scene. Go scripts. Alrighty, so at the very start of our ready scene, what will happen? At the very start of our def scene, what will happen is in our ready function, we'll go await get underscore tree dot create underscore timer. And then you can set this to whatever you like. I'm just going to set mine to like 4. So we'll go set it to 4.0. False, so then it's not happening whilst the game's paused, and then dot timeout. And then we're gonna do a variable here for the scene name that the player goes to, so this is like a public variable. I actually forgot to enter this on the monster as well, which I will do in a bit. So now after 4 seconds, what will happen is I'll go back to my monster script and just copy this line of code here, since it's pretty much just the same thing, and boom. So what will happen is after 4 seconds in our def scene, then then whatever scene you want to load will load. So yeah. So I'm just going to write in here level. And boom, since that's a scene I want to load into after def. And then with our monster as well, I forgot to enter in the scene name on this as well. I'm going to set it to def. And there we go. So now when the monster catches us, we'll die. So basically, it's important to make sure that, you know, the collisions in your level are all good, because AIs in Godot work sort of differently to how they do in Unity. So if you have like a collider, right, that isn't baked into your nav mesh in Unity, I'm pretty sure that nav mesh agents just ignore that collider completely, you know what I mean? But in Godot, it's completely different. Basically, the AIs will collide with any collider. It doesn't matter if they're in your nav mesh or not, they will still collide with them. So you'll want to make sure that your colliders are all good and wide enough, if your AI is a bit wider or thin enough, you know, that sort of thing. So yeah, so make sure that your collision is all good with your AIs. That is very, very important. In fact, I am actually going to, you know, make some edits to my level here to make sure that it is, you know, good enough and wide enough for my AI. Because what I think's been going on, and why I was getting killed at the door, is because the AI will run right up to the door, right? But then it can't get past because its collider is too thick for the doorway. So yeah, that's why I think it's been struggling. So what I'm going to do is, with my doorway too, I'm going to move this back into here, because I want to have that on, of course. So let's say, for example, with my collider here, I could change the transform of it from 111 to like 0.51 and 0.5. So then it's like somewhat skinnier and can actually fit through more walls and stuff like that. I just like to make... Oh wait, I accidentally just only did the mesh instance there. But yeah, I just like to make sure that I'm giving you guys as many tips as possible, since, you know, when making AIs in Godot, you might run into certain issues like I do when I'm making my games. You know, like with collision and stuff like that, there can always be them sorts of issues with AI in Godot. Now, there's nothing wrong with the AI struggling to get past the doors, since I kind of want the AI to anyway. I don't want the AI just walking through doors, you know what I mean? But what this shows is that this wasn't the perfect scenario to test this monster. In fact, I think the better scenario to test this monster would be via, like, you know, just having it in another part of the level where it can actually just freely run around and chase the player. So yeah, it's all about level design at the end of the day, making sure that your levels are properly designed for your mechanics and your creatures and stuff like that. So what I'm going to do is I'm actually going to have my monster over here, and I'm going to turn it off, so it's no longer going to be visible. And what I'm going to do is I'm actually going to make a new trigger, which is going to basically spawn in our AI. So what we're going to do is we're going to get one of these scare triggers here, since I've already got one in the scene. Actually, no, just in case you haven't done the scare triggers, I will show you how to do this from scratch. So what we're going to do is in our main level scene, we're going to go add child node, area 3D. And so this will be our trigger to spawn the monster. And then we're going to add another child node of this area 3D. And it's going to be a collision shape 3D. And make this a box. And so you just want to position this trigger wherever you want to. This will basically be the trigger that makes your monster appear. And now we're going to do a new script. So I'm just going to do a new script. I'm going to call this monster spawner. And then we're going to save it into the scripts folder. So what we're going to do in our monster spawn trigger is we're going to get rid of all this stuff here. And we're just going to write func spawn monster. And then in parentheses body. And we're going to be doing if body equals to get node root. And then plus get underscore tree dot current scene dot name plus, and then player. So if the body that enters the trigger equals to the player, what will happen is we're going to actually get a variable. So we're going to go at export var, and we're just going to be doing a monster character body 3D, since that is the type of our monster. And we're going to do monster.visible equals to true. And then it will set our monster to true, so then our monster can chase us. So that there is our monster spawn script. And yeah, so now what we're going to do is with our area 3D, you want to make sure that you have it selected. Go node, signals, and then where it says body entered, you then want to write in your method. So with me, it is spawn monster, I'm pretty sure. I'm pretty sure that's what my method's called. Oh wait, no it isn't. It's called, oh wait, I did on the wrong script, hold on. Make sure that when you connect your method up, you're actually connecting it to the right thing. So with me, it's on my monster spawner, so I want to connect it to that. Spawn monster, and yeah, there we go. That is all correct. So now our monster spawner is pretty much all ready. I can't think of anything else to do with it other than to fill in the inspector value. So if you select your monster spawner, you'll have an empty monster variable here. We're going to go drag this in, and boom, so now our monster will be set visible when we enter that trigger. So now what we're going to do is we're going to go test out the level and see how it all goes. Alrighty. Pick up the flashlight. Key. Now let's go. So now when we step through this trigger, boom, our monster is now chasing us. So as you can see, he is pretty slow right now, but that's because I set his speed to low before because he was getting right to the door. Oh. If you're wondering why them jump scare sounds are playing, it's because they're like scare triggers here, but yeah. So anyways, now our AI is following us around the map, as you guys can see. So yeah, it all works perfectly. So if we get caught, boom, as you can see the jump scare camera appears and then boom, death scene. So yeah, the AI does work as intended. Oh no, the AI is coming to get me. Looks like he's got himself caught in the door there. But yeah, be sure to make sure that your level is, you know, properly adjusted for your AI and stuff like that. And yeah. Alright guys, so I don't know why I didn't think of this before, but I did think of a good way to minimize the impact of collisions in your game to your AI. So let's say, for example, you get annoyed by your AI constantly getting stuck to your doors, and you're just thinking to yourself, you know what, I just want my AI to walk through my door. And, you know, speaking of AIs walking through doors, I will be teaching in probably the next part how to actually make your AI monsters open up your doors if you want them to be able to traverse around your level and you have doors that you want them to open. I'll be showing you guys how to do that. But what I'm going to be doing right now is I'm actually going to be showing you guys how to actually make it so then your AIs don't get stuck to your doors anymore and they can just go right through them for now. So yeah, so what I'm going to do is, as you can see here, if you go to your monster's parent object on the character body 3D, if you go down to the collision tab here, you can see that there is like a collision layer thingy here. So with our monster, it is currently set to 1. In fact, I am going to leave it at 1. But with our player, what I'm going to do is I'm actually going to go to our collision, and I'm going to set the other thing here to 2. And the reason as to why we're going to be doing that is because with our doors, so with our player collision layers, I've now got 1 and 2 set. And with our doors, we're actually going to have 2 set for this, and 1 is no longer going to be set for the collision layer of the door. And if you want to know how to set the collision layer of like a static object, you just go to the static body 3D node of the tree. And then you just go down to the collision, and then, you know, you can disable 1, turn on 2, and then yeah. Alright guys, so one thing which you'll want to make sure of is you'll want to make sure that, because I just tested it out before, and just by setting the collision layer to 2 for the door and the player, that doesn't actually mean that the player can then collide with the door, because I found that I was able to walk through the door and I wasn't able to actually interact with it anymore. What I had to do was I actually had to set the mask, the collision mask to 2, so then I could actually then interact and collide with the door, which is on the collision layer 2. So yeah. Oh yeah, that's another thing as well. With your raycast, you'll want to make sure that you set the layer to 2 as well if you've got your door set to the 2 layer, because otherwise you won't be able to interact with the door anymore since it's on the collision layer 2. And you'll want to make sure that you have collision mask 2 also selected on your player's raycast 3D. So yeah, now we're going to go back to the level again. I'm going to go play. So now if I go up to the door, yep, I can interact with it again. Boom, there we go. Now if everything goes to plan, our player should actually, our AI should actually be able to go through the doors and not get stuffed up by them. So let's make sure that our AI chases us down here. Close the door. And we'll see if we can walk through it. Yep, he can walk through the doors. So as you guys can see, that there is actually how you fix up your AI, getting stuck to your doors if you're ever interested in doing that. In my next tutorial, in part 9, I'll be teaching you guys how to actually make it so then your AI can open up your doors. So then, not only are they able to just, walk through them, but they can actually, open them up. So then it doesn't look like they're walking through them. So yeah, so that there, guys, is how to set up a basic horror enemy AI in Godot. If you guys did enjoy, be sure to like, comment, and subscribe for more. What I will do before I do end the video is I want to see how the monster looks at a faster speed, but anyways, as I do this, I will continue to talk. So yeah, sorry if this video felt like, you know, it was a bit all over the place. I wasn't really fully prepared when it came to doing this tutorial, and there were a few things which I was forgetting about, which then I was just remembering as I was continuing on. So yeah, overall, thanks for all watching. Be sure to let me know if you do have any, you know, problems in the comments, and maybe I'll be able to help you if I have time. I usually don't really have time to help other people in the comments, but I try to sometimes. But yeah. So overall, thank you all for watching. Hopefully this video helped you all create your basic horror enemy AI. As you can see, mine is now a lot faster. And he's pretty smooth, as you can see. He's following me pretty smooth, he's walking around pretty smooth. I have no complaints with this AI right now. He doesn't get stuck to the doors anymore, he, you know, is all good. So yeah. So overall, I am proud of this AI that we've got set up. And yeah. I guess one last thing that we could do actually to cap it off is we could actually add like a jump scare sound to our enemy AI, you know, since we've probably got a bit more time for that, so how about I do that? And also a light on the jump scare camera. We're going to need a light on the jump scare camera as well, so there are a few things to do before fully ending this tutorial, but overall, the majority of it is pretty much done, so yeah. Alright, so before ending this tutorial, I am going to show you guys how to do a jump scare sound, and also we are going to be like attaching a light to our jump scare camera as well, so then our you know, our monster can actually be seen in the dark when it jump scares us in the dark. So yeah, so what we're gonna do is we're gonna go monster, go add child node, and this will just be an audio stream player, and we'll call it jump scare. And then just add in your jump scare sound. So I'm just gonna add in the jump sound that I have. There we go. And boom, so that's pretty much that. Now we go into our monster script, and where it says if distance less than equal to 1 and court equal to false, we're going to go down here, and jump scare dot play. And also I'm just going to add this little extra line of code here, so if the jump scare sound isn't playing, then jump scare will play. And boom, so that's how we get a jump scare sound to play when we get jump scared. And now for the light. So what we're going to do is we're going to go to our jump scare camera, go add child node, and then omni light. And now with this light here, so then this isn't visible to our player. What we're going to do is we're going to make this visible on the, well, what layer should I do? I'll do layer 15. So it won't be visible on layer 1, but it will be visible on layer 15. And then we're going to go to our player, go to camera 3D, and make sure that it can't see anything on the layer 15. So I'm going to turn that off in the culling mask, and there we go. So now the player won't be able to see whatever is on layer 15 in the culling mask. So now we're going to go back to our monster, and with our jump scare camera, make sure that it can see layer 15, which it should be able to by default. And then I'm just going to edit my light a bit. Maybe set the range to like 2. Turn down the energy to like 0.5. There we go. And boom. So now that should be that done. And now how about before we end off this tutorial, we test it off one last time. So I'm just going to go play. Here we are in the main menu that we've made. We haven't made any settings yet or credits. But let's go play. Alright, let's test this out. Here he comes. So as you can see, we can't see the light that is attached to the jump scare camera of our monster. So if we die, boom, as you can see, there is the light and death. So yeah, that there is it for this tutorial. If you did enjoy, be sure to like, comment, and subscribe for more. Let me know what you want to see in future parts of this series. There are going to be a couple more parts. I'm not too sure much how exactly. I just want to show you guys how to make a proper horror game. At the moment, we've been like, you know, doing like certain mechanics and stuff like that, like the jump scare triggers and the AI. We will make it into a more fleshed out game soon. Right now, things are a bit messy, but yeah. I'll be sure to see you all next time in my next part or in my next video, depending on what it is. See you all soon, and bye-bye.